Hey there, and welcome to this explainer, where we're taking standard teaching notes and turning them into a focused, step-by-step masterclass on C++ basics. Whether you're cramming for an exam or just building your programming foundation from scratch, you are in the exact right place. Let's get into it.
So our core philosophy today is this. If you are a beginner learning C++, these are the concepts you absolutely need to understand before moving ahead. Seriously, mastering C++ takes a really strong foundation in these exact principles. It isn't just some old language with a few new commands glued on. It gives you incredible tools to organize your code and physically manage your computer's memory. But to use those tools without crashing your computer, you really got to know the rules. All right, here's our roadmap for this explainer. We're going to cover the basics of C++, custom data types, memory, and safety rules, followed by a predict the output practice test, and finally, a quick revision checklist. Section 1, the basics of C++. Let's look at the absolute primitives. Okay, so you want to get data in and out of your program. C++ handles displaying text and getting user input in a really cool way. Instead of messing with complicated format strings like older languages did, C++ uses what we call stream objects. Over on the left, we've got cout. You can just think of it as character out. It uses those two less than signs, which we call the insertion operator, to basically shove your data out onto the screen. On the right, we have sin, or character in. This one uses the extraction operator, those two greater than signs, to pull data in from the user's keyboard. Just follow the arrows, right? The arrows point towards cout to push data out, and they point away from sin to funnel data into your variables. Now, before you start writing massive chunks of code, you have to declare what your functions are going to look like. We call this a function prototype. It literally tells the compiler the function's return type, its name, and the types of parameters it takes, way before the function is actually used. Think of it as a security checkpoint, so the compiler can actually warn you if you try to pass the wrong arguments later on. Also, C++ lets you leave little notes for yourself called comments. You just use 2 forward slashes for a single line or a /* for a multi-line block. But hey, quick warning, C++ absolutely does not let you nest block comments inside other block comments. It'll just confuse the compiler and totally break your code. Section 2, custom data types. Let's see how C++ lets us organize our information. C++ gives us some incredibly flexible ways to group data. Look at this first row. A struct is basically like a house, where every variable gets its own separate room. If your struct has an integer and a character, they both live happily and safely in their own separate storage. A union, on the other hand, is kind of like a timeshare. All the members share the exact same memory location, meaning only one value can safely be active at a time. Then we have enum, which is simply a way to create a list of named constants, like, say, days of the week, so you don't have to use confusing random numbers in your code. And lastly, typedef. Now, this doesn't create a new type at all. It just makes an alias or a nickname for an existing type, just to make your code easier to read. All right, section 3, memory, pointers, and references. This is the heart of C++. Let's dive in. First up, we really need to talk about scope, which is essentially the specific neighborhood where a variable lives. Imagine you have a local variable named x inside your function that's set to 20, but you also have a global variable named x outside the function set to 10. How do you tell C++ which one you actually want? Well, you use the scope resolution operator, which is just those two colons. If you print just x, you get the local 20, but if you print : x, you are explicitly bypassing that local scope and grabbing the global 10. Makes sense, right? Okay, please pay close attention to this next part, because it's huge. References versus pointers. A reference, which we declare with an ampersand, is literally just another name, an alias, for a variable that already exists. It absolutely must be initialized the second you create it, and whatever you do to that reference happens directly to the original variable. A pointer, though, is a completely separate variable that physically stores the memory address of another object. We use an asterisk for these. Unlike a reference, a pointer can actually be left empty or uninitialized, and it requires you to dereference it to actually interact with the data it's pointing at. Let's look at a real code example so you can see exactly how this builds. We have an integer a set to 10. Next, we create a pointer p, and we store the address of a inside of it using the ampersand. Now, to actually change the value inside a using our pointer, we use the asterisk. This is that dereferencing I mentioned. By writing *p equals 25, we're essentially telling the computer, hey, go to the address stored in p and change the value you find there to 25. So when we print a, it's 25.
Also, just a quick side note, C++ does have a void pointer type. That's just a generic pointer that holds an address but doesn't actually know what type of data is stored there yet. Section 4, Safety and Rules. Now that we're messing with memory, we need some guardrails. Say hello to the const qualifier. It is going to be your best friend. It essentially locks a variable down so it cannot be modified later. It's way safer than using older C-style macros like #define because const actually respects C++ data types and scope. Next up is the bool type, which just represents logical true or false. Pay really close attention here. Behind the scenes, true behaves exactly like a 1 and false behaves like a 0. Also, check out that code snippet at the bottom, int age 23. This is called functional initialization. It's just a slicker, more modern C++ way of setting a starting value without even needing to use an equal sign. All right, let's break down a classic matrix that confuses almost every beginner: mixing const with pointers. Look at row 1. This is a pointer to a constant. The pointer itself can freely change where it's looking, but the value it's looking at is completely locked. Row 2 is a constant pointer. Here, the value it points to can be changed all you want, but the pointer itself is locked to that specific address forever. And row 3, that locks both. You can't change the address, and you can't change the value. Take a second to just let that sink in, because it's a very common exam question. So when you send data into a function, you can pass it by value or pass it by reference. Passing by value means you're basically handing the function a photocopy of your data. The function can scribble all over that photocopy, tear it up, whatever. Your original data stays perfectly safe. But passing by reference, using that ampersand, means you are handing the function the original document. Any changes the function makes will permanently affect your original variable. And there is one massive absolute rule here. Never, ever return a reference to a local variable inside a function. Because when that function ends, the local variable is destroyed, and your reference will just be pointing to dead, empty memory. Section 5. Predict the output. It's time to put all this new knowledge to the test. I want you to take a moment and really look at these two blocks of code. On the left, we create a variable a, make a reference r that points to a, change r to 50, and then we print a. On the right, we have a global n equal to 5, a local n equal to 9, and then we print n followed by : n. What do you think the computer is actually going to print out for each of these? Pause the explainer right now if you need a few seconds to figure it out. All right, let's see how you did. The answer to the first one is 50. Why? Because r is just an alias for a, so modifying the reference permanently changes the original variable. Simple as that. For the second one, the output is 9 followed by 5. Printing plain n gives you the local variable, which is 9. Then, using that scope resolution operator explicitly bypasses the local scope to grab the global variable, giving you the 5. Okay, round 2. Try to predict this next set. On the left, look very closely at how the function is declared at the top before it's actually used in main. On the right, look at how we are assigning numbers to Boolean variables. What is going to get printed? Take a moment. And the reveal. The correct output for the first block is 10. This works perfectly because that function prototype at the top set up the function safely before we even tried to use it. For the second block, the answer is 0 followed by 1. Remember, a Boolean only understands true or false. 0 translates directly to false, so it prints as a 0. But in C++, any non-zero number, like 25, or even -100, is instantly converted to true, which will print out as a 1. Section 6, Final Revision Checklist. Let's lock in everything we've learned. Here is your master cheat sheet. It neatly organizes all the core syntax and definitions we just covered. We've got our insertion and extraction arrows for cout and syn. We have the fundamental differences between structs and unions, the ampersand for our references, the asterisk for our pointers, those double colons for scope, and of course the protective const keyword. I highly recommend you pause the explainer right here and grab a screenshot of this. And hey, as you go off to write your own code, please avoid these classic beginner traps. You must never forget to initialize a reference. You must never return a reference to a local variable. Be super careful not to get your ampersands and asterisks mixed up when you're dealing with memory. Never try to change a const object, and whatever you do, don't nest your block comments. Finally, I want to leave you with a mini oral test. Ask yourself these 4 core questions right now. 1. What is a reference? 2. What does $p actually do? 3. Why do we use those 2 colons? And 4. What is the fundamental difference between a struct and a union?
If you can answer these clearly, out loud, right now, without looking back, then you have successfully built your C++ foundation. If you're slightly fuzzy on any of them, just jump back a few minutes and review. Truly understanding these concepts is the key that unlocks everything else C++ has to offer. Keep practicing and happy coding.